11.9, convert between degrees and radians. So we've been doing everything in degrees. And when I first started doing trick stuff with you, I said check the mode on your calculator because there is degrees and then there's also radians. Radians deals with pi most of the time. We'll get to kind of when it doesn't. But what a radian means is you're taking literally the radius and maybe stretching a piece of string to measure it. And then you're then taking that same string and now stretching around the arc part of the circle. So it's how many of these radii does it take to stretch along here. So you could see that this would be bigger than 1 radian. That's just in simplest terms what it means. But what we're going to learn is what is the relationship between pi and degrees and how to convert between radians and degrees. So the directions say, what fractional part of one semicircle does a labeled angle represent? Express your answer as a fraction in simplest terms. Then express the labeled angle in radian measure. So it's saying 105 degrees is what part of a semicircle? We know that a semicircle, half a circle, is 180 degrees. So you're simply saying that it's 105 degrees out of 180. And what I would like you to do is simplify that, and the quickest way is to go ahead and put your 105 divided by 180. And you know that on my big calculator, you just hit math, enter, and it'll change it. On here, you want to do where it says green F to D, so it's second, and then this table button to turn it into a fraction. So it'd be a 7/12 is really what you should put. So then 105 degrees is how many radians? It's literally that fraction of pi, because 180 degrees is equal to pi. We need to know that because all the way around is actually 2 pi. So we're going to say 7 pi over 12, or it's 7/12 of pi is what you're thinking. And here's a picture showing you that we're dividing the semicircle up into 12ths, and 7/12 would be 105 degrees. Okay, number 2 is a bigger angle. So we've got actually bigger than 180 degrees. It's going to be bigger than 1 pi. So it's going to be a mixed fraction or improper fraction. Either way, you're still saying 335 degrees is what part of a semicircle. We're always going to compare it to 180 degrees because that is pi. So I'm going to take 335 divided by 180, and then second table on this calculator, it'd be 67/36. So what is that in radians? It would be 67 pi over 36, or 67/36 pi. So here it's hard to see, but all of this got split up into 67 pieces. Okay, so then when converting between degrees and radians, use the following relationships. We've already talked about how pi is equal to 180 degrees. Everything gets compared to a semicircle. So we're going to convert without a picture. So when I see degrees, I think of the degrees being out of 180 degrees. So I know that 60 is a third of 180. And then you're saying it's that many pi. So really this is pi over 3. It's a third of pi is what you're doing. Okay, number 2 is 165 degrees out of 180. I would simplify that into 11/12. And then it's taking that times pi, so it would be 11 pi over 12. Number 3 gets even bigger, but we're still taking it out of 180. And that's just 4 times pi, so it'd be 4 pi. Okay, now when I'm taking an angle that's in radians and changing it to degrees is a little easier once you know what you're doing. So pi, we said, is equal to 180 degrees. I can simply replace it. So I'm taking 3 times 180 divided by 4. 3 times 180, 540 divided by 4 would be 135. So that means that 3/4 of a pi is 135 degrees, which makes sense. 3/4 would be here. So that's 90 plus 45 degrees would be 135. Okay, another one, 7/12 of a pi would be 7. Replace pi with 180 degrees. Multiply. That'd be 105 degrees. That's the easiest. The only problem is when now they just tell you this is a radians and it's not in terms of pi. You're not going to just add a pi in there. So if this is my radians, I'm going to put rad here. What you need to do is know that, I'm trying to think of the easiest way to say it, is to know that you need the conversion factor of 180 degrees is equal to pi. I want to put my radians, my like measurements, diagonal here so that they kind of cancel out. That's what I'm trying to do. So I'm actually going to take -4 times 180 and then divide that by pi. Pi button. And nearest tenths, this would be -229.2 degrees. So when it's a radian, you want to multiply by the conversion factor of degrees over radians. That's actually kind of what we're doing all along. If I go back to the 60 degree, I'm actually taking that times the conversion factor pi over 180 because I want my degree measurements to cancel out. So I'm taking 60 times pi over 180. We're simplifying this. Versus in these down here, I'm taking this fraction, which is already in radians, and I want pi on the denominator to cancel and 180 degrees on top. And I took 7 times 180 divided by 12. So I'm actually doing this every time of either 180 over pi or pi over 180, and you want your common label to be diagonal from each other.